Okay, I'm gonna go through all these problems that we haven't gone over yet. Already did 1 through 8 in class. Hopefully this doesn't slide around too much because I forgot my clipboard at school. But factoring, first thing you should always look for is greatest common factor, no matter what you see. And that's what we have here. They all have x. So we pull out an x, and then I think a lot of you are confused by this 3 plus b, but just remember, when you pull out a GCF, if you were to multiply, you should get what's up here, right? So x times x would be x squared, but really you should just realize it's 2 plus b, because x times x, remember you just add the exponents. 1 plus 2 plus b is 3 plus b, plus x squared plus 1, because you need that there. The reason that works, if we multiply like bases, we can add the exponents. So really that is the same thing as x to the third times x to the b, right? Because right, if you're multiplying, you add those, you get 3 plus b plus x to the third plus x. So if I pull an x out of that, it's easy to see that that should just change down to x squared times x to the b plus x to the third squared plus 1, because x times x squared would be x to the third, that x to the b is just chilling there. So that's why that works. And that's it. I don't think that's factorable anymore. So this one, again, greatest common factor, it's 1/3. I think they all have a pi, third pi with 2/3 pi, that's got a third in it, and an h, right? Yep, 1/3 pi h. So now that times r squared would give us that one, plus big R squared, minus, I saw a lot of people putting 1/3, but remember it's 1/3 times what gives you 2/3, so that's 2. And then we have little r, big R. And you might not immediately recognize that, but that's still factorable, because if you rearrange them, it looks a lot like this. Good old, you should recognize x squared minus 2xy plus y squared. That's just a perfect square, where if you have x and x, y and y, minus and minus, x squared minus 2xy plus y squared. Well, that's exactly that, just with little r and big R instead of x and y. So if you rearranged it, doesn't matter if you put little r first or big R first. R plus r squared, it's really just r minus r times r minus r, and then the stuff in front. And of course you could rewrite that as r minus r squared, doesn't matter. Down here, look for a GCF. There isn't one, because that's just got a y, it doesn't have an a. And then also, if you look for GCF and you have more than 3 terms, you should immediately just go to grouping, try grouping them. So I'll try that, see what happens. We might have to rearrange, I don't know. Might as well just try it straight up first. Let's see, those have an a in common, so I'll pull an a. So that leaves a y minus 1. Those have a y in common, but I can also see my signs will be switched. That front one's negative and that's positive, but I want positive and negative, so I better pull a negative y. So negative y times ay is that, and minus 1. Negative y times negative 1 is positive y. Parentheses match, so it worked. So I got a minus y times a y minus 1. And that would be all, because those are not factorable anymore. Let's see here. It's not GCFable. I think I did. This is the one I did on the board, but I'll just do it again. No GCF. Did grouping work? I don't remember how we did this one. I'll try try grouping. I don't remember what's going to happen. Let's see. This is fun because I have no idea what's going to happen, and it's filming, so I can't take it back. So let's see, x squared x plus 3y. Oh, it's not going to work. I can already tell. Y squared. Oh, maybe, actually. Never mind. Oh, no, I think they're different. That's right. Y squared 3x plus y. That's x plus 3y. That's 3x plus y. It doesn't work. What did we do? I don't remember. I know the answer because I recognize it. The 1, 3, 3, 1. I don't know if Stanbury ever showed you guys Pascal's triangle. This thing where you go like this: 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, and you use it for multiplying binomials out. I recognize it just because of that, but if you don't, there was another way. What was it? I'm drawing a blank right now. Oh yeah, I grouped the cubes. So it was like x to, I'm not going to give you one like this on your test. It was x to the third plus y to the third, and then I grouped those two, 3x squared y plus 3xy squared, and then that was sum of cubes, so it was x plus y, same, opposite, positive. And then that was GCF, so plus 3xy times x plus y. And then you GCF it again, because they both these terms have an x plus y in common. So you get x plus y times, so you pull that out, and you're left with x squared minus xy plus y squared plus 3xy. Then if you combine like terms there and there, you get the x plus y is still chilling out front. I'm not going to mess with that, but you get x squared plus 2xy plus y squared. Then that's factorable. Paper sliding. X plus y times x plus y. So really you got x plus y, x plus y, x plus y. So it's x plus y to the third. That'd be your answer, which you could have recognized right here. That's 0, first power, second power, third power for a binomial. Like I said, I'm not going to give you one like that, but it's fun. Ooh, this one's fun too. This one's very long. It's getting hard to write down at the bottom of the paper here. So you can do sum of cubes first, because I think they're both cubes. That's 4 cubed. That's 9 cubed. That's a cube, that's a cube. You can do that first and then go from there, but I think most of you did difference of 2 squares first and then did sum of cubes twice. Shouldn't matter either way, so I'll try to do it the way you guys did it. 8a plus, what's square root of 729? I don't know. What is it? Third, no, 20 something. Drawing a blank. It's getting late. Because it can't be 30, because 30 would be 900. 28, no, that ended in a 4. How do you get it? How do you end in 9? 20. Doesn't make sense. 23 is 225, 625. 27. B. Oh, and these should be square root of that's third, square root of that's third, and then 8a minus 27b, both to the third. Now we got sum and difference of cubes. Oh, duh, I could have thought of that because I knew it needed to be a cube. Oh, didn't think of that. So, third root of that would be 2a, third root of that would be 3b, and then that one is squared to go here, so 4a squared, multiply the 2, 6ab, and then that one squared is 9b squared. Same, opposite, always positive. Then that one's going to be the exact same letter number combination, just different signs. So 2a minus 3b, 4a squared plus 6ab plus 9b squared. Those should be next to each other. I just don't have room. And it's too hard to write with one hand with the paper sliding around. So that would be your whole answer all next to each other. Neither one of those should be factorable further. The only reason that worked over here was because we had that extra term. When you do difference of cubes formula, that's usually never factorable on its own. But on this one, we added that 3xy in and it became factorable. Those probably aren't. I don't know. I'm not going to think about it. This one, I don't know if I wrote this one wrong or if there just really isn't much to do. Because if you GCF it, you got an x squared, it looks like, and a y. And that'll leave you with x squared y plus 2x plus 3. And then that's not factorable because of the y. So yeah. So I either messed up writing it or I'm missing something. But it doesn't matter, I guess. I don't see anything. Hey, I can Google it, I guess. Or not Google, but this other great site that does everything for you. But I'll do that while I work on the next one. Well, I guess I can't turn the page. So you have to sit here and wait. Let's see. Oh, I can pause it. That's right. Yeah, that really was it for that one. I looked it up. Irreducible factorization. We had the right answer, so makes me feel better about life. Let's see, solving equations now. Include complex solutions. Some of these are really long. Should have some extra paper here, but I don't. So. This one's pretty simple. When you're doing the ones with square roots, remember you're going to do squaring of both sides of the equation. But like on this one, you can't just square individual terms. You have to square the whole side. So on this one, if you squared this whole side, you'd have these two terms, then you have to do distributive property, and it can get a little ugly, and the radical won't go away. But if you just add the 3 to get the radical by itself, 2 plus 3x equals 2x plus 3. Now we can square both sides. And when you square a square root, it just goes away, so we have 2 plus 3x. And then that's pretty easy to square. It would just be, what, 4x squared plus 6 is 12x plus 9. Get everything to one side and factor because we have x squared and x in the same equation. So we'll just bring it all over here. And I think this one gets kind of ugly because I just randomly made it up. Yeah, that's not factorable. So we'll just go straight to quadratic formula. Negative b plus or minus square root b squared 4ac all over 2f, 2 times 4, might as well just do that. So 4 times 4 is 16, times 7 is 70, 112, right, Riley? So negative 9, he won't watch it anyway, but 81 minus 112 is negative 31 over 8. If we could reduce that radical, we would, but 31's prime, so just bring out the negative, right? Whenever you have a negative under square root, it's just going to be whatever it normally would have been, but with an I. And then the only thing when you write complex numbers are ones with the imaginary part. They're always in this form. They have a real part and an imaginary part, and they're separated by the plus or minus signs because they always occur in conjugate pairs. Don't know what you know about that, but so really we just need to divide both of these by 8. So it would be negative 9/8 plus or minus the square root of 31 over 8 I. Probably be the best way to write that. This one gets ugly, I think, Because unlike this one, you can't isolate the radical, so you can't just square it and the radical will go away. Even if you add that one over here, you're still going to have two different radicals that you can't combine, so when you square it, you got to do distributive property. So I like working with positives though, so I would add it over here. So add that and get over that, and now square both sides. Well, that's 3x plus 4 squared is just 3x plus 4. And if I square that, I'm actually going to write it out so I don't make a mistake. 3x plus 4 plus 2x minus 1 times the square root of 3x plus 4 plus the square root of 2x minus 1. So then distributive property it. That radical times that radical, since they're the exact same thing, it's just 3x plus 4. Then I have plus, and remember when you multiply radicals, you can just multiply the stuff underneath. So really, when I multiply that one and that one, I will have the square root of 3x plus 4 times 2x minus 1. And then when I go here, I will have another one of those. So it will be plus another square root of 3x plus 4 times 2x minus 1. So just for the sake of saving room, I'll just throw a 2 right there, because I'll have two of them. And when I combine like terms, it'll be two of those radicals. Plus, I have that radical times that radical. They're the exact same. So it's just 2x minus 1. And we are equal to 3x plus 4 over here. Well, seems like I should get, now you only have a single radical, so if you get all the other crap to one side and square both sides again, you'll get rid of the radical. So if I minus 3x minus 4, I can see what's going to happen there. It's all zeros. But then I also have this, so I'll subtract 2x and add 1. So I'll have minus 2x plus 1 over here equals 2 times the square root of that stuff underneath of it. You can divide by 2 now or square both sides now, it doesn't matter. I'll divide by 2 now. So I have negative x plus a half equals the square root of that stuff. Now I'll square both sides and the radical will go away. However, the ugliness won't. So that sucks. That's squared, let's see. Negative x plus a half times negative x plus a half is positive x squared minus half x minus another half x, so that's minus x, plus 1/4 equals 3x plus 4 times 2x minus 1, right? That's the stuff that was underneath there. Well, I got x squareds now and x's, so I'm going to have to factor. So I got to get everything all on one side, which means I have to multiply this all out. So what is that? 6x squared minus 3 plus 8 is plus 5, and minus 4 equals all that stuff. I'll bring it over here just because I want it to be positive, so I'll subtract x squared. I will add x, and I will subtract 1/4. So now we got 5x squared plus 6x minus 4 1/4. That's not useful, so let's see, that's 16/4 minus, so minus 17/4. I don't think that's going to be factorable. There's no way. I don't like, so might as well just go straight to quadratic formula. Let's see, negative b plus or minus the square root of b squared minus 4 times 5 times negative 17/4. Ooh, that's nice. Hey, you know what? That might be factorable actually, because that works out nice under there. All over 10. But anyway, if you don't immediately see it's factorable, if it looks too hard to factor, just go here. Because now I see 17/4 times 4, I know what's going to happen there, and those 4s are just going to drop out. Oh, it didn't work out nice. I was thinking 7 times 5. I thought it was going to be 35 and then 1, but that didn't happen. Let's see, 5 times 17 is 50 and 30, 85. So the negative times the negative is positive, so we're going to add 85 to 36. What is that, 120? No. Is it 121? No way. 85 and 36. That's 110 plus 11. Wow, it does. It does work out nice. This is exciting stuff when you're a math teacher. So that tells me that I could have factored that. So now I feel like a wuss. So I get negative 6 plus or minus 11 over 10. So negative 6 plus 11 is 5 over 10. And negative 6 minus 11 is negative 17 over 10. So I got x equals a half, and x equals negative 17 tenths. So now well, never mind. I was going to say, looking at those, you can figure out what you would have needed to do to factor that, but obviously it wouldn't have been very nice no matter what, so whatever. Here's another one. This is probably factorable. I would bring this over, keep the x squared positive, so subtract 5x, subtract 6. So 6x squared minus 5x minus 6 equals 0. Let's see, that's got to be factorable, right? I don't know. I'm going to try. I'll guess 3 and 2. And if I guess 3 and 2, if I put a 3, that's a 9 and 4. Oh, yeah, there it is. Boom, first try. 9 and 4 will make negative 5 if the 9 is negative and the 4 is positive. Right? 6x squared minus 9 plus 4 is negative 5. And then minus 6. We got it. So set each factor equal to 0. So subtract 2 divided by 3. I should slow down. There. Subtract 2. I'm not doing it on the other one. I can't take it. X equals negative 2/3. And add 3 divided by 2. So 3/2. There's your two answers. That one, x, bring it over, x to the 4th minus 7x squared minus 18 equals 0. Factor it like normal, because that is the square of that. So just go x squared, multiply to negative 18, add to negative 7, I think is negative 9 and positive 2. So then set each factor equal to 0, or that can be factored further, x plus 3, x minus 3. Squared plus 2. That can't be. So set each factor equal to 0, so you'll get x equals negative 3, x equals positive 3, and then that one, if you set it equal to 0, subtract 2, so you get x squared equals negative 2, and then you got to square root it, so you get the square root of negative 2. Oh, and remember when you square root, you got to have plus or minus. That's how we're going to get our 4 answers. And the square root of negative 2, well, it's just I again, so we got plus or minus the square root of 2 times I. And there's our 4 answers. Let me know if you need a further explanation on I, how that works. Let's see, so this one, just subtract that, so we got x minus x to the 1/2 minus 12 equals 0. Again, that is the square of that, meaning if I take that and square it, I get that. So it's just regular factoring. And I just use that one, x to the 1/2, x to the 1/2. What multiplies to negative 12 adds to negative 1, it would be negative 4 and positive 3. Set each factor equal to 0 now. So you got x to the 1/2 minus 4 equals 0. Add 4 and eat 4. You also have x to the 1/2 equals negative 3. So then you could square both sides, so you get x equals 16. And then you might think you can square both sides here and get x equals 9. But does that work? I don't think that works. That does not work. Because this right here, just that part right there, is not true. You cannot take a number raise it to the half power and get a negative result. Or you can't, half power means square root. So the square root of whatever I put here, I ain't going to get a negative answer. So this is just, I actually saw it and I was like, they probably think it's 9, but it can't be. So the only answer is 16. And hey, look at our leading power. It's 1. So there's really only one answer. The other way, you could have got 9, and if you plug it in, it doesn't work. 9 minus 3 minus 12 is not 0. So lots of different ways, but the best way would just be to see that and realize it's not possible to have that equation ever be true. Hey, we got a something squared minus something, so it's just going to be regular factoring. Subtract the 6 over, equal to 0. So we got, hey, look at that thing is the square of that thing. So I'll just put parentheses. I'll have x plus 2, parentheses, x plus 2, because x plus 2 times x plus 2 is x plus 2 squared. Multiply to negative 6, and there's a negative 1 in front of that, so add a negative 1 would be minus 3 plus 2. I can combine like terms now, because those parentheses, I just put them just to kind of separate it to show you it's like, it's this thing, and then this thing again, just kind of helps you see it. But now that we're done with that, positive 2 minus 3 is x minus 1, and then 2 plus 2 is 4, something like that. So we get x equals 1 and x equals negative 4, and that's it. Just 2 answers. Because if I square that, I'll get an x squared. You could have actually squared that and then subtracted an x and subtracted a 2, and like combined all your like terms, and then if you subtract the 6, you go all the way down and factor it, but you'll get that. But I don't really want to do that right now. Video is getting long enough. Back to, I know this one pumped a lot of you. It's still, hey, look at, I have a thing squared, and then, well, you might be freaking out because there's nothing else. But really, if you just subtract that over, you got some stuff squared minus 8 times some stuff equals 0. And this stuff in here is exactly the same. So if I GCF it, which is supposed to be the first thing you do during factoring always anyway, I will be able to pull out a common factor of all that stuff, which will leave me inside, let's just parentheses, this stuff times that exact same stuff will give me the stuff squared minus 8, because this stuff times negative 8 is negative 8 times that stuff. I was doing that, I mean, I could put letters in it too. I think I showed some people, I was like, hey, just put a squared equals 8a and solve it. And that kind of messed them up, but it'd be a squared minus 8a equals 0. Factor out the a times a minus 8 equals 0, which is exactly what I have here. Except now I can fill in the blank. It's x squared minus 25 over x. Then I pull that out, and that would be x squared minus 25 over x. So I got all that. Set my factors equal to 0 now, so I'll have x squared minus 25 over x equals 0. Multiply both sides by x. So x squared minus 25 equals 0. Hey, that's x plus 5, x minus 5. So 2 of my answers, plus or minus 5 right there. And then this one I have to set equal to 0, so I have x squared minus 25 over x minus 8 equals 0. Add 8. I'm going to do 2 steps. Add 8 and then multiply by x. See, x squared minus 25 equals 8x. X didn't go away, so it's a little harder to factor. So now I got to subtract the 8x. So x squared minus 8x minus 25 equals 0. Factor that. Let's see. Is that factorable? Oh, no, it's not. So that's only 5 and 5, or 1 and 25, and neither one of those are going to add to 8. So the good old quadratic formula again. Negative b plus or minus square root of b squared minus 4a negative 25 over negative 16. Wow. Well, I just did b. It's stupid. 2a is just 2. Alright, there we go. I knew that didn't feel right. So now, let's see, negative 4, negative 25 is positive 100, so I have 8 plus or minus the square root of 164 over 2. Is that for real? Is that real? Did I mess up? B squared minus 4a is 1, c is negative 25, negative times negative is a positive, yeah, alright. So I gotta simplify that. 164, what is that? 2 times 164 is 2 times 82, which is 2 times 41. 41 is it prime? Yeah, it's prime. So I can just pull that out 2. So I have 8 plus or minus 2 root 41 over 2, right? I just simplified that radical, which was on your quiz you just took. So I'll divide both of them by 2, and you'll get your other two answers. 4 plus or minus the square root of 41. And then the last one. Long story short, do order of operations, that's 0. I remember that when I made this one up. And then that's difference of squares. So just x plus 3 times x plus 3 minus 3 equals 0. Hey, that makes that one real easy, doesn't it? Right? Square root of that, plus, minus 3 and 3. Done. So I got x plus 6 times x equals 0. So set each factor equal to 0, x equals 0. Set that one equal to 0, subtract 6, x equals negative 6. And that's it. I guess I was going fast, probably mumbling and changing volume when I get excited with my voice, so sorry about that. But I challenge you to sit in a room by yourself and talk to an iPad for 30 minutes and then listen to it, and you'll hate it. So okay, that's all I have to say. Make sure you bring questions to class.